In this class, now I am going to explain you kinetic energy and potential energy formulas of an object which executes simple harmonic motion, and also I explain you the energy remains constant in the path followed by an object which executes simple harmonic motion. First let us see kinetic energy formula. See, I am going to derive the kinetic energy formula of an object which executes simple harmonic motion. For this, I would like to take a simple pendulum. You know, in our earlier classes, we have discussed about simple pendulum which follows simple harmonic motion. See, this is a simple pendulum. Now pull it and leave it, and which makes oscillations. So here, this is the maximum displacement covered by this bob. See, this is the mean position, let it be P. Now this is a maximum displacement. This if you would like to take this as some point Q, you can. This point in MS Q, the distance covered by displacement made by this bob be capital A. So from here to here. So this is distance capital A. So this is the path followed by simple pendulum, and in the meanwhile somewhere here take a bob over here. So let us take this point as R. Now the displacement between the P and R be small x. Small x. So this is the shortest distance from P to R, x. Now you know displacement equation of this bob is x equal to capital A into cos omega t. Capital A means what? Maximum displacement from here to here. Omega means what? Angular velocity. T, time. Now differentiate this displacement equation with respect to time, so that you will get velocity. So you will get minus A sin omega t. Is this t? No. So that follow the chain rule, so that you will get here omega. You know the differentiation. So here minus omega A into sin omega t you can write as 1 minus cos square omega t. Now send this A inside. So that what do you get? Root of A square minus A square cos square omega t. Now in place of this, in the next step I can write x square. If I write x square there, I will get here root of A square minus A square omega square. In place of this you can write x square. So this is the velocity of this bob at R. Why we got minus sign? Because you know, so if this bob moves from P to Q, whose velocity decreases. So we will find the maximum velocity of this bob at mean position only. Yes. Now write the kinetic energy formula. Kinetic energy of that bob at R 1 by 2 m v square. V square means if you take square on both sides, you get 1 by 2 m omega square A square minus x square you will get. That is the kinetic energy of that bob at a position R. Keep it aside. Half m omega square into A square minus x square. Right. Next, Find the potential energy of this bob at R. Potential energy. For that, I would like to take this relation. F is directly proportional to minus x. You know meaning of x. Displacement of that bob from the mean position. What is capital F? A restoring force which generates in the bob. Restoring force. That restoring force which works toward the mean position. Bob is moving that side. The restoring force which generates inside of the bob will try to bring the bob towards the mean position. Observe that. If you move from left to right towards the Q, your x is increasing. So if x increases, displacement increases, automatically restoring force also will increase, which brings the bob towards the mean position. Observe that. So both are working in opposite direction. That restoring force will work towards the mean position, but the displacement is towards the Q. Both will be in opposite direction, so that we got here minus sign. If you remove this proportionality symbol, here I am adding a constant k. Okay, keep it aside. Next, students, observe carefully. So now the bob is at R. The distance from P to R is small x. Now I want to do a very small change in x. If you do very small change in x, automatically some work will be done on the bob. You know, work done. W is equal to force into displacement. You read that formula. See, here also, see, I want to take the small changes, small work will be done on the bob, which is denoted by dw. What it is? A small work which is done on the bob to get a very small change in x. Bob is there, suppose any object which is there on the earth. If you want to do any small change in the object, some compulsory you have to do some work now. So that work is dw. W is equal to F into S. Already you studied. So here dw is equal to minus F into dx. Okay, work done to get small change in x is how much? Dw is equal to minus F into dx. So remember, like a standard result. Okay, right. Now in the next step, in place of F I am going to write minus kx. Again here you may get a doubt, sir, why we have got this minus sign. You know, work and x both are in opposite direction. Bob is moving towards that side. Okay, so automatically the force which is generated inside of the bob tries to bring the bob towards the mean position. Okay, to bring the bob towards the mean position, so some external work is done on it. That external work is equal to work done on the bob is equal to minus F into dx. Just you remember, like a standard result, df is equal to dw. Don't get confusion between this w and omega. So one more alphabet which we have used in the beginning, x equal to capital A cos omega t. There omega represents angular velocity or angular frequency of that simple harmonic oscillator. But here W means work. Okay. In the next step, I am going to replace this capital F by minus kx. So what I will get? dw, which is equal to, so here kx dx you will get. Hereafter, I am going to integrate on both sides. Integral of here 1 into dw. So which is equal to k is constant, keep it aside, x into dx. After integrating, you will get w here because 1 is there. Here x square by 2. You know the integral of x dx. But you know, students, omega, this is omega, not work done. Omega square is equal to k by m. This relation which you have studied. So now I want to make k subject. omega square m you will get. Now replace this k by this. If you replace that k by this, so you will get 1 by 2 m omega square x square. So, okay, to write the difference between omega and w, you better to use this work done with capital U, potential energy. So, which is equal to half m omega square x square. This is potential energy formula of that simple harmonic oscillator at this R. Okay, students? Right. Now, we got two formulas. Okay? For KE and PE. KE means kinetic energy and potential energy. Okay, this is done. Now, let us go to discuss energy remains constant in the path followed by that simple harmonic oscillator. See, first I would like to check the energy at P, at mean position. At mean position. At mean position, you know students, x equal to 0. Am I right? Because no displacement, no? So x is 0. Then what about KE plus PE? Find KE plus PE. KE is 1 by 2 m omega square a square minus x square, as we have discussed, plus PE 1 by 2 m omega square x square. Now put x equal to 0 because you know no displacement at P, mean position. If you write x equal to 0 here and here, I will get this part becomes 0, this part becomes 0. So that I will get 1 by m omega square a square. So this is the sum of the energies. Kinetic energy plus potential energy at mean position. Keep it aside. Now let us go to at maximum displacement at Q. At Q. As you know, at Q, x equal to a. So here in this, when the bob is at Q, you know x equal to a. So if you write x equal to a in this, okay, what I will get? Ke plus Pe. So x equal to a, if I write here, this part would become 0. 0 and something 0. Okay, here half m omega square a square you will get. Observe one thing. When the bob is at mean position, so this part is getting 0, which means that there only we will find kinetic energy. When the harmonic oscillator at mean position, which will have only kinetic energy, which do not have potential energy, because we are getting potential energy as 0. Now when you go to the maximum displacement place, so what is happening there? Their kinetic energy is getting 0. There that bob will have only potential energy. Okay? Right. Now here both energies are constant. Whichever energy you found at mean position, same energy you have got at Q. See, 1 by 2 m omega square a square, 1 by 2 m omega square a square. Now, not only these 2 points, I am going to check this energy at any point in the path. So, I am taking at R. You can take anywhere, but in between the P and Q, I am going to check whose energy levels at R. At R, now add both of them. Ke plus Pe. Ke plus Pe. Ke is how much? Multiply these two with half m omega square. If I multiply here, I will find half m omega square a square minus half m omega square x square. So potential energy half m omega square x square. Now on simplifying this part can be cancelled. 1 by 2 m omega square a square you got. Okay students, I hope you have understood. So this energy remains constant in the path followed by the simple harmonic oscillator. For that I checked at 3 points. One is at mean position, we got this much. There we observed that potential energy became 0. There we got only kinetic energy. And at Q, kinetic energy became 0, potential energy we found. Both are equal. And in the meanwhile, I took at R. So there we found both. And on the after simplification, we got 1 by 2 m omega square a square only. So these three results as same. Hence, I can conclude that the energy which remains constant in the path followed by a simple harmonic oscillator. I hope you have understood this class, students. I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Thank you students. Thank you one and all.